So my dear students, today we will discuss a question regarding the bending moment. A shaft simply supported at the ends is subjected to loads of 2 kN and 5 kN as shown in the figure. Determine the shaft diameter. If the material selected is C40 with yield strength 324 megapascal and take the factor of safety equal to 3. So this is our question. Figure is given. We have the two loads 2 kN and 5 kN. Further, the distance between those points are also given, and it is simply supported at the ends. So we have the two end supports. Further, it is given that the material is C40. So I will select C40 for sigma y equal to 324 megapascal, and megapascal is same as Newton per millimeter square. So 324 Newton per millimeter square. For the factor of safety is given. Factor of safety is equal to 3. So maximum stress for the design stress, maximum stress is also called the design stress. Maximum stress equal to strength by factor of safety equal to 324 by 3 will be equal to 108 Newton per millimeter square. Now we can see that these loads will produce a bending of the beam. So we have to select the bending equation. So for bending, our equation is sigma max equal to m by z into kt. So this is our equation. Equation 2.1b, sigma max equal to m by z into kt. Since nothing is mentioned about the stress concentration factor, I will take kt equal to 1. Further, sigma max, we have already found that value 108 Newton per millimeter square. Then value of Z we can find from table 1.3a. For circular shaft, Z equal to pi d cube by 32. Z equal to pi d cube by 32. So I have that value also. I substitute Z equal to pi d cube by 32, where d is the shaft diameter. So if we can find the bending moment m, I can find bending moment m, I can find the shaft diameter. So now we have to find what is the bending moment. To find the bending moment, it is a very easy step. First thing we have to do is that we have to convert this perspective view to the front view. So I will be drawing that front view in which I can see the loads and the distance between different points. Okay. First I will mark all those points A, B, C and D. Okay. Now we have to find what is the support reactions at RA and RD. I can see that these external forces are acting downwards. So for time being I will assume both RA and RD are acting upwards. I will find the support reactions RA and RD. To find the support reactions, first I will equate the vertical forces. So sum of upward forces RA plus RD equal to sum of downward forces, that is 2 kN plus 5 kN. 2 kN plus 5 kN equal to total comes up to 7 kN. Now our second step is step 2 is to find the moments about the support reaction. So step 2, we find the moments about any of the supports. I am taking the moment about point A. So moment equal to force multiplied by distance. So if I take the moment about point A, sigma ma will give 2 kN multiplied by 0.3. It's a clockwise moment. Further, 5 kN multiplied by 0.8, 5 into 0.8, it is also clockwise. So I am adding with 2 into 0.3 equal to RD into distance is 1 meter. So RD will produce an anti-clockwise moment, RD into 1. So I am equating clockwise moment and counterclockwise moment, from which I will get the value of RD. I will get RD equal to 4.6 kilonewton. For the substituting in the step 1, I will get RA as equal to 2.4 kilonewton. So I have found the values of RA and RD. I will write that values in the figure. So I got RA equal to 2.4 kilonewton and RD equal to 4.6 kilonewton. Now we will find the bending moments. To find the bending moments, I have to draw the bending moment diagram, BMD. To draw the bending moment diagram, bending moment at the supports A and D will be equal to 0. Now we have to find what is the bending moment at point B and C. Bending moment at point B. To find the bending moment, it is an important step. Find what is the force to the left of point B. To the left of point B, there is only one force, that is Ri equal to 2.4 kilonewton, and since it is acting upwards, its bending moment will be positive. So bending moment at B will be equal to 2.4 kilonewton multiplied by 0.3, that much kilonewton meter. To the left of point C, I have two forces, Ra acting upwards and 2 kilonewton acting downwards. So bending moment at point C will be equal to 2.4 multiplied by distance is 0.8 minus 2 kilonewton multiplied by distance 0.5. That value will be equal to 0.96 kilonewton meter. So since it is higher, and here it comes to 0. So bending moment at point B will be 2.4 into 0.3 will be equal to 0.72 into 10 power 6 Newton millimeter. Further at point C, it is equal to 0.96 into 10 power 6 Newton millimeter. We can see that bending moment at point C is higher when compared to bending moment at point B. So I will note that bending moment at point B equal to 0.72 into 10 power 6 Newton millimeter, and bending moment at point C equal to 0.96 into 10 power 6 Newton millimeter. Since we have to design for the maximum bending moment, we will take this value for the calculation, maximum value. Now we'll substitute in our equation. We have already get what the value sigma max equal to sigma y by factors of t equal to 324 by 3 equal to 108 Newton per millimeter square. Is that we have found from the table for circular shaft it is pi d cube by 32. Further kt equal to 1, we are neglecting the stress concentration factor. M is the maximum bending moment at point C, it is equal to 0.96 into 10 power 6 Newton millimeter, from which I can find what is the shaft diameter. Okay, thank you.